Catus, Maximus here. This is the more of a basic teardown video of this Makita 6302H heavy duty half-inch 550 RPM 6.5 amp drill. And so I say it was possibly the best. There is the Makita spade handle drill that is great, but as far as pistol grip style drills, this is one of the better ones Makita made. I did look it up, so it does look. They had a cheaper version, which is the non-H. It had a plastic gearbox, and unfortunately, they used some sleeve bearings in combination with ball bearings. However, on this unit, it appears with the heavy duty that they did use all ball bearings. Of course, Makita is trying to compete with some pretty established players, especially in this time when they were really working off all their sales of their cordless drills in order to try to make all this, basically build their company. That's the easiest way to say it. So I'll open up. Drills are pretty simple. The chuck is going to be the hardest thing. They don't use a lock screw. And Makita is one of the first where they just torque the chuck at the factory to very high levels. And it really makes it a bear to remove them. It really does. You can blow out gears. I've cracked gearboxes. Porter cables have also been doing it for a long time, and I've destroyed 2 of them because it was just such a bear to remove the chuck. The Makitas, fortunately, they have a flat, I believe that's 17 millimeters across those 2 flats, but you need a cone wrench. And I've had these Makitas where I've bought an expensive, not real expensive, but a Park Tools bicycle cone wrench and actually just split them open. So you really need to buy a box wrench and grind it down to fit in there. There may be a way to get the spindle out apart from the gearbox, but unfortunately, the spindle is pressed into the bearing and you can risk damage the bearing just trying to get the spindle out to, say, put it in the vise. So it's always going to be just a bit of a challenge here. Let's see if we can't get the switch for some reason is caught in this side. But you can see where these are Makita, they are pretty expensive. They do use folded contacts on the motor here. You can see that right there. So unfortunately, they're not using welded contacts, and they didn't put any extra protection right there at the back of the motor either. So I wish they would have done that, but it's not the end of the world. Older tools, they used to really make the motors very physically resistant to actual debris and particles getting in there, and they just turned out over the years that really wasn't what was taken out the motors and power tools, and that's just a result of all the factory warranties and them saying, you know what, it isn't crud that got in there that broke apart a bunch of wires. Some things that are really nice. This switch is an Eaton switch. If you look up Eaton, they are a premium industrial corporation making various power and control electronics. So seeing an Eaton switch in there is really pretty nice. That was an expensive part using a real premium brand. You can see their funkiness with the separate reverse switch down at the bottom. We can see that the variable speed transistor is external to the switch, and so it gets a little bit of extra cooling, which is pretty nice to see. Let's take a look at the brushes in this to see how worn out they really are. They're kind of funky. I could already tell that this armature, if we look at it, you can see that there is a bit of wear, and you can feel just a tiny bit of a lip. When we pull out the brushes, they still have some life left in them, but not really a ton. One thing that's a little bit more annoying is that these are special holders. This little back clip, there's a wire attached to the brush for higher conductivity, but it's all a proprietary integrated unit. If you could, these brush sizing, the width and length, or not length, but the width and height of the brushes all follow general standards. So you can always find brushes that will fit into that slot, but you would have to actually cut that wire, and it wouldn't be quite as much conductivity, but in most situations it would be just fine. But since it's a plastic holder, you don't have additional conductivity through the holder. It would be just relying on the spring if you just did kind of a homemade brush job. So it's a little bit annoying in this situation because you really want the wire because there is no conductivity in the brush holder, and you're kind of stuck buying Makita's proprietary brushes. There are some, you may be able to modify some to fit in there and solder it. Find some other brushes that fit, that have a wire that you could solder to this top connector, but that's definitely just a little bit annoying here. It's something that I'm gonna have to order, and gosh, I wish Makita wouldn't have done that because it does make it a hassle. Even soldering it, you're stuck trying to keep the spring compressed and solder a little wire to this. It's really just kind of annoying. So Unfor Wish Makita once again would have done something different there. Otherwise, it's just pretty easy to replace the cords. These types of connectors are spring-loaded push-in. So what you do is you need to take a sharp pick, not like an O-ring pick, but just a regular automotive pick set, and you'd have to push it in there to push the little barb that's in there, and then you can pull out the wires to easily replace the power switch or the power cord. Really not too bad. So let's get this gearbox apart. Makita has also been known for doing this right here, where they use a machine thread screw in the plastic, and this screw, it bottoms are out right there. So they make up for the shallow thread by having like a huge amount of engagement. That's like 20 or 25 millimeters, 3/4. Actually, that's probably closer to an inch of engagement, and that's, you can see how long this bottom screw is, but of course it has to go all the way through this. And here we are. As soon as we get that apart, the diaphragm and everything wants to come loose, so you'll want to hold that. And it's going to be kind of tight getting this gearbox off because it wants to just pull the whole motor out, and I didn't pull out the brushes, so I want to be careful, but it does use some ball bearings in there. See, what you have to do is you just have to kind of wobble it and wiggle it until it all wants to come out. And we can indeed see a couple things here. It is, they're using all ball bearings, but they didn't use a needle bearing. They just figure it's so low RPM, it's still a sleeve bearing. And this is something I've seen in a lot of Makita drills. They just, something that they do to try to be a little bit more price competitive. You know, DeWalt's and Milwaukee's, they have every place where there's a rotating part has a rolling element bearing. So it's always something I wish Makita would have done, is just put in, you know, it's one little needle bearing. Might as well put it in, and it just makes it a little bit more premium instead of having a sleeve bearing, even though there's ball bearings everywhere else on both sides of the motor. On both sides of this idler gear, which is going to be difficult to pull out. You can see when I was pulling it out, the bearing came halfway off this little post. Whoop, and of course I dropped it. Nothing that's in compressed air and a little bit of oil won't fix, so it's always really exciting to try to get like these idler gears out because of the way it's in a blind hole. You can't press it out. So all you can really do is just find a wood block and get, you know, an area set up with a couple holes to the stems, and then just actually hit against it. It's part of the hassle of doing some repairs on a lot of these power tools. They're really, and as far as the expense, I mean, heck, on this Makita, just the motor armature is $80 something. You would never replace the motor. If the motor burned out, you just buy another drill. And looking inside this gearbox, I'm kind of wondering why they offset that gear so far. It looks like they could have moved it. It looks like it could have fit right in the middle. It really does. Or more offset down further, and it would have held up a little bit better. We can see that they at least do something. This is actually a roll pin, so they'd be pretty easy to extract. I would probably, you know, if you're into it, replace that with a solid pin, but this is going to be interfacing with just a little hole right here. That helps prevent the diaphragm or the back part of the gearbox from shifting on the front of the gearbox, so the gears maintain their alignment. This is something that's missing on the new DP 4000 and DP 4002 series drills, is this pin that makes sure that the diaphragm stays aligned, and it's really a big issue, because once those gears start to get off alignment, they can wear out 10 times faster. It's crazy. Gears, their lifetime is dictated really by how even the contact is. So not really a lot else. We do have a helical cut on the first stage from the motor to this, to the idler gear. However, it is straight cut just because they don't need it's more expensive to cut helical gears. And at the slower speed reduction, they just don't need them. So they are straight cut. Of course, the teeth on the second stage are thicker than they are on this first stage, which is also something nice to see. We can see that it is not a sinter gear. It's a machined, hardened, induction hardened. We can see around the hardening, the discoloring around the edge, where it's a different color in the center. So softer in the center, and then very hard teeth around the edge. And a final quick note about the chuck. So there's a snap ring that holds on this back gear. If we hold the idler gear, we can see the spindle shifting back and forth. That's just because there's a Woodruff key, you know, a little slot in the gear and a little slot in the shaft here with a little piece of metal that locks them both together. And so that gear would be, you know, you'd have to hammer it against a piece of wood to release the idler gear, And this is going to have a ball bearing on the other side, which is trapped behind this. It's kind of a whole exciting situation. You may need to remove the snap ring so both gears can come out. Once that happens, I'm sure this shaft is pressed through this bearing. So if you can't get off the chuck, you'll have to, I wouldn't hammer on that, but you have to use a gear puller to push on this to push it out, which could damage this bearing because you're putting stress on the inner race, which is, of course, putting stress on the balls and micro-denting the races. So that, although on a drill it's not, a big critical issue, it's something to mention. Anyway, that was the teardown. That way I could do my review on this, and then people could just have a quick idea of what it looks like inside and know that really it's a pretty good drill. They could have done a little bit heavier duty of an armature, at least more physical protection, but it's really not so bad. The brushes are the worst part because the way they're set up, they're fairly proprietary, and it would require a bit of effort to make any other brushes that you got at a tool supply or something to replace them. So you do have to kind of order those Makita 401 brushes. Anyway, I'm just going to put a little bit of extra grease in here just to freshen this up. We can see that they just use a basic lithium grease, not even a molybdenum grease or anything like that. So plenty cheap, but kind of what I expected. This heavy duty one is better than the all plastic version. And Makita hand drills tend to be a little bit expensive for the overall build quality that you're getting out of them. I don't know if I've done many teardowns in my other drills, but pretty much all of them use 100% ball and needle bearings. So that's why I bring that up with the Makita. Anyway, I really appreciate everybody who's been watching and subscribing. And if you haven't subscribed, please do. Until next time, Catus Maximus out.